We now want to talk about significant figures in calculations. So the main reason why we care about counting sig figs and values is that allows us to know how to round answers. And this really is the important takeaway. This is not a math class. We're going to do a lot of math. We're going to do a lot of work processing numbers. But these numbers that we're looking at represent real values. They represent real life measurements. And so as a result, there is an inherent accuracy. There's an inherent exactness to them. There's accuracies we need to be thinking about. So when we process, when we do calculations with those numbers, we need to maintain that level of exactness by rounding. So one of the biggest takeaways, whenever you do a calculation, you need to round your answer. And the purpose of significant figures and counting them is they are a guide that tells you how to appropriately round an answer based off of input, based off the exactness of your input numbers that you're doing your arithmetic on. The rules for rounding are based off the type of math. If you're doing multiplication or division, you round your answer to match the lowest number of total sig figs among the input numbers. So for example, 3.43 times 7.2, if you plug that into a calculator, you get 24.696. So if we look at our input values, 3.43 has 3, 7.2 has 2. We choose of these which one has fewer total sig figs. That would be 2. So then to round, we count out 1, 2 from the top, from the high value, so the 20 point. So 24, we need to round on the 4. We can see that after the 4 is a 6. So we follow our standard rounding rules and we end up with 25. The reason why we're doing it is this 6.96 is meaningless. Because this 7.2 is a rounded number, there are digits after that too, right? There are values that keep going. You did not measure this number with enough exactness in order to get that additional information. There is a value after the 4. It's just not, it's probably not 6. It is probably, we're assuming greater than 5. That's why you're rounding up, but it is probably not exactly 6. You cannot be confident that it is 6. So you want to round to 2 sig figs to match the fact that you only started with 2 sig figs. For addition, our rule is going to be addition and subtraction. Our rule is going to be slightly different. We round to match the fewest digits after the decimal among all the numbers we're adding together. So for example, 3.4 plus 465.23, we start at the decimal point, and that's where we count. So I have 1 right there, I have 2 right there. And then for the digits for rounding, the 468.63 is kind of the calculator answer, but we only want to match just the 1 digit after the decimal point. So we count our inputs after the decimal point, we round based on after the decimal point. So the correct answer would be 468.6. So all of our numbers, we want to be rounding in this way. And we expect to do this for all calculations that we do throughout the term, throughout the course, right? And so this is a part, now granted, if you don't round correctly, it's not like you're going to get everything wrong, but that is going to be a part of any sort of grading on tests or anything like that. So the motivation behind this. So Dr. Duncan's dog weighs about 71 pounds in his dreams. Wookie eats 1.34 pounds of food. What is Wookie's new weight? So my dog is trying to lose some weight, but he's eaten 1.34 pounds of food. How is that going to affect him? Well, if we think about it, we would just add them together. 71 plus 1.34, that would give us 72.34. The thing is, he weighs about 71 pounds. Try getting him on the scale. There are digits after there. We just don't know what they are. They could be anything, right? They could be any sort of value between 0 and 9. And I just don't know what they are. What that means is that the 3, 4 in my answer is meaningless, right? It could be anything So we should just round them out. And so I should get 72 as my rounded answer. Another way you can kind of think about what's going on here is if you just look at the language. My dog's weight, Wookie weighs about 71 pounds. Okay. If afterwards you come out of a calculation and you say he weighs 72.34 pounds, that is a much more precise answer. There's a lot more information. So the answer needs to maintain the aboutness that I started with. So he weighed about 71 pounds. He ate some food. He now weighs about 72 pounds, right? So I'm maintaining that sort of kind of approximate nature of the information. And we would always want to do this, and sig figs just kind of give us a guide that we can count digits and values and move them on. There are fancier ways to do this, but they're really, you don't get that much, a lot more work for not much better bang for your buck. So let's look at actually doing some rounding. So I've got some calculations. I put the arithmetic up there and shown the calculator answer. So one quick thing to note, when you are doing a calculation, do all of your arithmetic, then round. So rounding is going to lose information. You don't need to round until the very end. So basically you can multiply 80 numbers together and then count all their sig figs and then do the rounding at the end. So do all your math, then round at the end. So when we want to round, it's going to be a question of what type of arithmetic process are we doing? Okay, what type of arithmetic process are we doing? If it's multiplication, then all the digits matter. And if it's addition, we're only counting sig figs after the decimal point for all my numbers. And then just count sig figs for all your inputs. So this first one I'm looking at, I can see I'm doing multiplication, right? I can see I'm doing multiplication, or division would be I count everything. And so 3.54 times 6.732 times 8.32, I get 198.276. So I know I'm doing multiplication. I'm going to count all of the digits. So I can see all of them are non-zero digits. So I don't really need to do anything too fancy. And what I want to do is I want to find the lowest total among them. So I'm basically just comparing this 3, 4, and 3. So 3 is the lowest number among them. There's multiple 3s, but that's okay. What that tells me is my answer should be rounded to have 3 digits. Okay, so I can do that. I can round to 3 digits. In order to do that, I look at this next digit. It's a 2, so I'm going to keep it down. Correct answer is 198. So multiplying those values together, I should expect that my answer would be 198. For my second example, I can now see that I'm dealing with addition. And so because it's addition, I only want to look at the numbers after the decimal point. So I'm looking at them. I can see I have the 2, the 3, and the 2. So for my answer, when I round it, there should be 2 digits after the decimal point. I count in the same way. Basically everything in addition, counting and then rounding, are all based on after the decimal point. And so I should round the 0, round at the 0. I can see the 3 is low, so 24.90. Excellent. For this last one, I'm doing 4.2 times 55.4. I can see it is multiplication. So I'm going to count my sig figs of my inputs. I got 2 and 3. That means I'm going to round this answer. Okay, so I need to round it to 2 digits, matching the 2 that I had right there. So I want to match that. So if I round it to 2 digits, I'm rounding on the 4. You can see that the 3 is there. So I'm going to round down. The correct answer is 240. Now, that rounding may make you feel uncomfortable because it feels like we're throwing away information. We had that 3 and we've replaced it with a 0. But just because it's on the left side of the decimal does not mean it is a meaningful value. Because 4.2 only had 2 sig figs, if we wanted that digit, we need to know what's here. That 3 is just as meaningless as the 6 was up here, and we should round it out. And so we get 240. We cannot be more precise than the tens place from this calculation that we had based on our input numbers. So it really is 240. if we wanted to convey that the 0 was significant, we could put a decimal point right there. So if we put a decimal point right there, zeros at the end are significant when you have a decimal point. And so normally you wouldn't do this in you wouldn't say 240 with a decimal point, but because if you're trying to convey significance, you can do that. But that number is not, this one is not significant. We want it to be 240. Another common mistake is just dropping the 0 and writing 24. That is wrong. We do need that 0. It's not significant in the sense that it doesn't convey what the value is, but it does convey magnitude. So you do need that 0 there. If you were doing scientific notation, you wouldn't. It'd be 2.4 times 10 to the second. So, speaking of scientific notation, we also want to look at evaluating multiplication division in that context. So I've got I got a multiplication and division problem. I'm still going to look at what type of arithmetic process are we doing, multiplication or is it addition, and then I count. And we can see that in both cases here, I'm doing a multiplication and division. And so that means I'm going to look at total sig figs. And when I'm counting sig figs in scientific notation values, it's actually easier. I just count the whole thing. I count, so that would be my 2, that would be my 4. It's the same values, so this is 2 and this is 4. Okay, and so we can count those total digits. Whenever you have a scientific notation expression, every single number is significant. The 10 and the exponent are not significant. Those only correspond to magnitude. How big or small is the number? But when we round, we're going to match this 2 that we have in both of them. So 1.7, 7.7. We know we round based off that next digit. So because the 7 is high, we round that to 1.8. Because the 2 is low, that stays 7.7. Let's look at one more kind of situation. So boxer dogs weigh on average 62.3 pounds. You can tell how overweight my dog is. What is the average weight of 2 boxers? So if you plug that in, 62.3 times 2 gives you 124.6. Okay, so that would be the average weight of 2. The thing is, when we go to round this, if we're looking to count sig figs, we would think that 2 may be the lowest number, right? Because it's only one digit. But it comes from counting dogs. 1 dog, 2 dog. So that is an exact number. What that technically means is it has infinite significant figures. It would just be 2.000s, right? Like we talked about before. And so what that means is it looks like it only has 1 sig fig, but that's because it's exact. Basically, functionally, we just don't count the digits of an exact value in order to determine the lowest number of sig figs. Instead, we count the 62.3. That is a measured value. On average, these dogs weigh 62.3 pounds. There is certainly more digits after that, 3. And so we would say there are 3 sig figs in that value. So we should round our answer to have 3 sig figs. So be 125. So on average, 2 boxers weighs 125 pounds together. And so whenever we have exact numbers, we just don't care about them when it comes to counting for sig figs. When it's measured values, those inexact numbers, that's what we're really looking at. That's where it actually matters because you're only representing so much of the value. When you write 2 in this expression, you've got the whole value because it really is 1, 2